Picture this. It's August, right around 3 o'clock in the afternoon.
Pretty much the worst part of the day.
Exactly. The sun is just beating down outside.
Yeah.
And you're walking through your house, and everything feels, perfectly fine.
That's cool.
Right. Totally comfortable. But then you open that one specific door. Maybe it's the bonus room over the garage, or maybe that back bedroom on the west side of the house.
Or a sunroom addition the previous owner slapped on.
Yes, exactly.
Yeah.
So you step across the threshold and bam, it feels like you just walked outside onto the hot pavement. It is suddenly, 10 to 12 degrees hotter than the rest of your house.
Almost everyone listening to this has that one stubbornly uncomfortable room that just completely defies the central thermostat. You're essentially stepping into a totally different climate zone inside your own home.
Right, and the central system is just powerless to fix it. So you learn to live with it. You avoid the room entirely from June to September, or you put a loud, rattling box fan in the doorway.
Because in the back of your mind, you figure fixing it means dropping $15,000 to rip out your drywall and rebuild the entire HVAC system.
But that is the mission of our deep dive today. We're unpacking a stack of sources, including some extensive engineering explainers from Mitsubishi Comfort, alongside, hard-earned field insights from the HVAC technicians at Hartzell's Heat and Air. We are going to definitively solve this exact problem room dilemma without that $15,000 nightmare.
When you finally do call a professional about this specific problem, the industry's default answer is almost always a mini split. But let's be honest, most homeowners have absolutely no idea what that word actually means. Contractors just throw the term around assuming we all speak HVAC.
Oh yeah, totally.
So our goal today is to provide a plain English translation of this technology. We're looking at the physics of how it works, the real-world costs, and maybe most importantly, when installing one is the absolute wrong move for your house.
Okay, let's unpack this. Because to solve the problem room, we first have to understand the vocabulary these contractors are using. If we think about a traditional central air conditioner, it's highly inefficient by design. It's basically like trying to cool down someone sitting in your backyard by turning on a massive industrial fan in your front yard.
Right, and hoping the cold breeze makes its way through a maze of incredibly long, leaky cardboard tunnels in your attic.
Yeah, exactly. A mini split completely abandons the tunnels. It's like handing that person in the backyard a cold bottle of water and a personal fan right where they're sitting. There's no middleman losing the cold air along the way.
That paints a much more accurate picture of the mechanical difference. Let's strip away the jargon entirely. You'll hear contractors say mini split, ductless heat pump, or ductless mini split. They're all describing the exact same product category. The core concept is right there in the word ductless.
So it bypasses that leaky network of metal tunnels entirely. But if I buy one of these systems, what is actually showing up in my driveway? What are the physical components?
You're looking at two main pieces of equipment. You have a small outdoor unit containing the compressor, which is the engine doing the heavy lifting. And then you have an indoor unit placed directly inside the room you want to cool.
And no massive metal duct tying them together.
Right, no ducts. They're connected by a pair of simple copper refrigerant lines and a small electrical wire. Those lines just pass directly through a tiny 3-inch hole drilled through your exterior wall.
Oh, wow. Just 3 inches. When most people try to picture that indoor unit, they're probably thinking of that sleek white box mounted high up on a wall near the ceiling, right?
Yeah, the wall-mounted head is the most common visual. It's usually about 3 feet wide and maybe 8 inches deep.
Yeah.
But the technology has evolved far past just a box on the wall. Mitsubishi's catalogs show several architectural variations, like flush ceiling cassettes.
What do those look like?
They sit up between the joists in the ceiling, so all you see from below is a subtle square grill. It looks very similar to a standard recessed air vent.
Oh, so it practically disappears into the drywall.
It does. And if you have a room with vaulted ceilings or no attic space above, they manufacture floor-mounted units that sit low against the wall. They look a lot like a traditional low-profile baseboard radiator.
That's super convenient.
My personal favorite from an engineering standpoint are the short-ducted units. They can actually be hidden entirely above the ceiling, totally out of sight. They use incredibly short, maybe 5-foot runs of dedicated ductwork to feed 2 or 3 nearby rooms simultaneously.
Wow, without ever tying into the main central ductwork of the house.
Exactly.
Okay, I'm going to play the role of the skeptical homeowner here for a second. Because if I'm listening to this and I already have a massive, very expensive central AC unit sitting outside my house, Why am I bypassing my existing ductwork at all? Isn't it just infinitely cheaper to have a guy run a new metal tube from my existing system right into my hot bonus room?
It definitely seems like the most logical, economical solution. But what's fascinating here is that the technicians at Hartzell's routinely see this exact scenario turn into a $2,000 mistake.
Wait, really? Why?
It comes down to the physics of how a central system is engineered. Your original central air system was carefully sized for the original square footage and layout of your house. It operates on a closed equation of static pressure.
Meaning the system only has a finite amount of air it can actually push.
Think of your central blower motor like a heart trying to pump blood through veins. If you suddenly add an extra mile of veins, a new room, or a massive new duct run, the heart doesn't magically pump more volume.
So the pressure just drops everywhere.
Yes. Tapping into that original system doesn't create more cold air. You're just robbing Peter to pay Paul. Usually neither room gets enough air. You end up spending $2,000 to install a duct that basically blows a whisper of air, and the bonus room stays hot.
That makes a ton of sense. But avoiding those leaky ducts doesn't just save you from wasting $2,000 up front. It fundamentally changes how much power the machine actually needs to draw. And this is where the sources keep using the phrase inverter-driven.
Right, you see that everywhere.
To a non-HVAC person, that just sounds like expensive marketing jargon. What does inverter-driven actually mean in plain English?
It is arguably the most important technological leap in modern HVAC. A traditional central AC only knows two speeds. Completely off or violently 100% on.
Just slamming on and off all day.
Incredibly inefficient. When the thermostat clicks, it slams on, blasts massive amounts of cold air until the room hits the target and slams off. An inverter-driven compressor operates more like a modern car with the highly sensitive gas pedal.
How so?
It modulates the electrical current from AC to DC, allowing the compressor motor to spin at variable speeds. It constantly monitors the thermal load of the room, meaning how much heat energy is actively entering the space, and adjusts its output to match that exact load.
So it's not just turning on and off, it's reading the room. If the sun goes behind a cloud, the machine eases off the gas.
Yep.
And if 4 people walk into the room to watch a movie bringing all their body heat, it revs up just enough to handle the extra load. The temperature stays incredibly stable instead of yo-yoing up and down.
And that subtle dynamic adjustment requires significantly less electrical energy than a massive central system violently starting up every 20 minutes, which unlocks another massive benefit: zoning.
Because the cold-producing coil is directly in the room.
Right. That specific room gets its own dedicated thermostat.
Which fundamentally changes how we actually live in our houses. Let's say that hot bonus room is where the kids play video games. You can set the mini split to a perfect 72 degrees at 3 in the afternoon while they're in there.
And then at night, when the room is empty, you just let it drift up to 78 degrees.
You aren't paying to cool an empty room. Trying to do that with a traditional central system requires complex motorized dampers inside the ductwork that cost a fortune and restrict airflow.
Exactly. So we're saving a tremendous amount of power in August by running this highly efficient system. But we have to look at the other side of the calendar. What happens to that same bonus room when January hits?
Here's where it gets really interesting. Because usually, the room that is an absolute oven in the summer becomes an icebox in the winter. The insulation is bad, or it's over an unheated garage.
This is where the term mini-split is a bit limiting. Every modern unit we're discussing is actually a ductless heat pump.
Meaning in the summer, it absorbs the heat from inside the room and pumps it outdoors. But in the winter, it mechanically reverses that cycle, absorbing heat from the outside air and pumping it indoors.
And their winter capabilities have advanced to a point that surprises even contractors. Mitsubishi's engineering documents detail their hyperheat lines. Historically, heat pumps were notorious for failing when the temperature dropped below freezing.
Right, I've heard that.
But these hyperheat units are engineered to deliver full 100% heating capacity, even when the temperature outside drops to 5 degrees Fahrenheit.
Wait, stop right there. 5 degrees Fahrenheit. That sounds like magic. How in the world is a machine pulling actual heat energy out of 5-degree air to warm up my house?
It's all about thermodynamic pressure manipulation. Heat energy exists in the air all the way down to absolute zero.
Oh, wow.
Inside that outdoor compressor, the system drops the pressure of the liquid refrigerant to an incredibly low level. Because boiling points are tied to pressure, this super chilled refrigerant can actually boil and absorb whatever trace amounts of ambient heat exist in that freezing 5-degree outdoor air.
That is wild.
Then the compressor takes that slightly warmed gas, squeezes it under immense pressure to spike its temperature up to over 100 degrees, and pumps that intense heat inside to the wall unit.
That is absolutely fascinating. So for places that regularly see cold snaps in the teens or even occasionally dip below zero, it's more than enough to keep that problem room incredibly cozy without ever turning on your central gas furnace. But I have to ask about the noise.
Yes, the noise factor.
Because if I'm putting a machine directly on my bedroom wall, I do not want it sounding like a jet engine spinning up while I'm trying to sleep.
It's a logical concern. But the hard numbers are incredibly reassuring. The indoor head operates somewhere between 20 to 30 decibels on a low or medium fan setting. Because the inverter ramps the motor up slowly, there are no jarring clicks or sudden rushes of air.
Just for reference, how loud is 20 decibels?
To put it in perspective, it's actually quieter than the hum of a standard kitchen refrigerator.
So it's basically just a whisper?
Less than a whisper. You usually have to look at the indicator light to know if it's actually running. And the outdoor unit is just as impressive. Because it's inverter-driven, it doesn't rattle the windows when it turns on like a traditional AC condenser.
Okay, we've established the mechanics. It cools, it heats, it's whisper quiet, and it sips electricity. But what if my problem isn't just one room? What if my entire upstairs level, like 3 bedrooms and a bathroom, is a total nightmare? Can this technology scale up to handle that?
It scales incredibly well. This is where the industry distinguishes between single-zone and multi-zone systems. Everything we've discussed so far is a single-zone application. One outdoor compressor connected to one indoor head.
Right, and obviously I don't want 4 separate outdoor units cluttering up my backyard if I want to cool 4 bedrooms.
And you don't have to. A multi-zone system allows you to connect a single, slightly larger outdoor unit to 2, 3, 4, or sometimes up to 8 independent indoor heads.
But does each of those indoor heads still get its own thermostat? Or do they all have to be set to the same temperature?
They are completely independent. You could condition an entire sprawling upstairs floor with a wall unit in the master bedroom, a ceiling cassette in the nursery, and a floor unit in the office. Each room gets its own remote control.
Oh, that's amazing flexibility.
Yeah, the outdoor unit acts as the central brain, routing the exact right amount of refrigerant to whichever room needs it at that moment.
So I'm naturally skeptical. It sounds like a miracle cure. It fixes the heat, it fixes the cold, it's quiet, it saves money, there has to be a catch. I want the hard truth. When is a mini split the completely wrong answer for a house?
It's vital to recognize the limitations of the hardware. The technicians at Hartzell's outline 2 very specific scenarios where pushing a homeowner toward a mini split is doing them a disservice. The first is what we might call the Band-Aid scenario.
Let me guess. My whole house is sweltering because my 15-year-old central AC is gasping its last breath. The contractor quotes me 15 grand to replace the whole thing, and I think, why don't I just buy a single mini split for the living room, sleep on the couch all summer, and use it as a cheap lifeboat?
You hit the nail on the head. If the central system for the entire house is actively failing, putting a mini split in one room is just delaying the inevitable. You're slapping a localized Band-Aid on a systemic failure.
Right, because you'll eventually have to replace the main system anyway.
Exactly. By the time you finally replace the dying central system, you will have wasted thousands of dollars on a lifeboat you no longer need. In that scenario, bite the bullet and replace the central system.
That makes perfect sense. What is the second scenario where this technology fails?
The second is what the industry refers to as the 8-room house. Imagine you have a long, narrow house, maybe an older farmhouse or a sprawling ranch, with 8 small, totally compartmentalized rooms.
Okay.
If you try to abandon central air entirely and put a ductless head in every single one of those 8 rooms, you run headfirst into 2 massive problems. First is the initial equipment cost. Buying and installing 8 individual indoor units and the massive outdoor compressors to run them will end up costing you significantly more than a perfectly sized traditional central air system.
Right, because you're multiplying the copper lines, the electrical runs, and the physical hardware by 8.
And the second problem is the maintenance burden. This is a reality check every homeowner needs to hear before they buy. Because these units bypass your central ductwork, they also bypass your massive central air filter. Instead, each individual indoor head contains its own washable mesh air filter.
Okay, washable sounds easy enough. What does that involve?
Yeah. The front panel of the wall unit hinges open. You pop the 2 plastic filters out, rinse them under the kitchen sink to clear the dust, let them dry on a towel, and snap them back in. The actual labor takes maybe 5 minutes.
And how often am I doing this?
During seasons of heavy use, the dead of summer or freezing winter, You need to do that every 4 to 8 weeks.
Which is totally fine if I have one unit in my bonus room. 5 minutes a month is nothing. But I see where you're going with the 8-room house.
Right.
It's not even about the 40 minutes of actual labor to clean 8 filters. It's the mental load. As a homeowner, keeping track of 8 different filters spread across the house that all need washing every single month is just a recipe for failure.
Yeah.
It becomes a part-time job you're guaranteed to fall behind on.
And this raises an important question regarding longevity. Because when you inevitably fall behind, the system punishes you for it.
What happens when you ignore those filters?
The indoor unit loses its ability to pull air across the cold evaporator coil. The system basically suffocates. It loses cooling capacity, the internal coils actually freeze over into a block of ice, and the blower wheel gets packed with heavy, damp dust.
Yikes.
The data is clear. A mini-split that gets its filters washed regularly and receives an annual deep clean from a professional can easily last 15 to 20 years. But the units that are completely ignored for a decade are the ones that suffer premature compressor failure and require massive repairs.
The maintenance is non-negotiable. If you buy the machine, you are committing to the filter washes.
Got it. So let's assume the person listening fits the ideal profile. They just have that one stubbornly uncomfortable bonus room. Their central system is mostly fine, and they are perfectly willing to spend 5 minutes a month washing a filter. What is the actual damage to their wallet? The cost is usually a pleasant surprise for people who are used to bracing themselves for central AC prices. For a standard single-zone installation, one outdoor compressor and one indoor wall unit fully installed by a professional, you're generally looking at roughly $4,000 to $7,000.
Which is a chunk of change for what some people incorrectly assume is just a fancy window unit. But for context, as we mentioned earlier, a full central system replacement on that same house is going to run anywhere from $12,000 to $18,000.
You're paying a fraction of the central system cost to permanently solve the specific problem you actually have. Now, if you move to a multi-zone setup to solve a hole upstairs, the costs do scale up. A 2-zone system might run $7,000 to $10,000, and a 4-zone system might push into the $12,000 to $16,000 range.
The Mitsubishi documentation heavily emphasizes finding a diamond dealer for the installation. Is that just an extended marketing tier, or does that actually mean something for the homeowner's bottom line?
It is a critical distinction to make when you're getting quotes. Mitsubishi Diamond dealers are contractors who have undergone extensive advanced technical training specifically on the software and physical tolerances of these inverter-driven systems, because they are mechanically far more complex than traditional central air.
And what does that mean for the warranty?
More importantly, when you use a certified dealer, the manufacturer usually extends the warranty on all parts and the compressor out to a full 12 years.
12 years of absolute peace of mind on the most expensive parts is definitely worth taking the time to seek out the certified contractor.
Okay, so I signed the paperwork with the diamond dealer. Walk me through installation day. Because having HVAC contractors in the house usually means weeks of noise, dust, and massive disruption.
That's the beauty of abandoning the ductwork. It's incredibly non-disruptive. In most single-zone cases, it's a one-day job. The crew shows up in the morning. There's no tearing up the attic insulation, no cutting massive holes in your drywall, no week-long mess.
So they just mount it right to the wall. Yeah, they set a small concrete pad or mount a bracket outside for the compressor. They mount the metal bracket for the indoor head on your wall. They drill that single 3-inch hole through the exterior. They run the lines, connect everything, vacuum down the lines to test for leaks. And they're usually packed up and out of your driveway by 2 or 3 in the afternoon.
I do want to touch on that 3-inch hole, though. Because as a homeowner, the idea of a contractor taking a drill bit and coring a hole completely through the exterior wall of my house induces a lot of anxiety. People worry it's going to ruin the aesthetic of the room or look like a terrible industrial pipe sticking out of the siding from the outside.
It's a very common fear before the installation, but it's largely unfounded once the work is done. On the inside of the room, that 3-inch hole is positioned completely behind the chassis of the indoor unit itself. You never even see it.
Okay, good. And on the outside?
On the outside of the house, the copper lines coming out of that hole are immediately encased in a clean, slim plastic cover, often called a line hide. That cover runs neatly down the siding directly to the outdoor unit. It can even be painted to match the exact color of the house. The consensus from homeowners is that after a few days, it just blends into the architecture and they completely stop noticing it.
Okay, so to bring this all together, we've covered the physics of the inverter drive, the actual real-world costs, the non-negotiable filter washing, and the incredibly fast install day. The technicians at Hartzell's give us a perfect summary of the core value proposition here. They call it Dave's Take, and the advice is so incredibly practical.
Oh, I love Dave's take.
Right. Dave says, pick the worst room in your house, the one you've been sweating in and complaining about for years. Put a single ductless unit in that room, and you instantly fix a 10-year comfort problem for less than the cost of one car payment a month for 2 years.
It really is about redefining what we expect from our homes. For decades, we've just accepted that our personal comfort is dictated by the physical limits of a 20-year-old duct system, or by which way the sun happens to be facing at 3 in the afternoon.
Yeah, we just settle for being uncomfortable.
But understanding the physics of this technology proves that you do not have to live at the mercy of your home's original floor plan. You can take precise control of the environment in the specific spaces you actually use.
And that leaves me with a really fascinating idea to ponder. We just spent this deep dive talking about how this technology, these highly efficient heat pumps and mini splits, allows for such perfect, precise room-by-room temperature control. Will future architecture just abandon the one massive central thermostat model entirely?
It's very possible.
Think about it. Maybe the houses of tomorrow won't have central heating or central air ducts at all. Instead, they'll be designed with hyper-localized, personalized microclimates engineered into every single room from the start. You like your bedroom at 68, I like the office at 74, and the house just handles it perfectly, dynamically adjusting the heat and cooling right where we sit.
Just perfectly tailored to every room.
Exactly. It could fundamentally change not just how we fix our existing houses, but how we design, build, and live in our spaces from the ground up. Something to think about the next time you walk into that sweltering August bonus room.